All right, so we are looking at the second and third objectives of the same section as yesterday. Um, this is really about the same, so it's kind of another day of practice at factoring and solving equations. The only difference today is our equations are going to have a degree higher than 2, so a higher exponent than 2. So we're still going to solve them by factoring like we did. We're going to look for a GCF, and then we're going to factor what remains looking at what our options are. So just keep this in mind, though. The highest exponent of the problem, or if you're looking at 3 and 4, if you were to multiply those problems, 5x times 2x squared is 10x cubed. So the highest exponent is typically how many solutions you're going to have. So it's either going to be 3 solutions or less. It's never going to be more than that, but it's going to be, most of the time, it's going to match that highest exponent. So we're going to expect to have 3 solutions on number 1. So let's factor this really quick. First, what is the GCF? Both of those numbers are divisible by 3, and there is an x in common, so we can divide by 3x. That would leave us with x squared minus 4. So we got to look at that resulting binomial. And hopefully the lights are flashing in your head and saying that is a difference of squares. So it's going to factor very easily if you remember the pattern. Hopefully you still do. We just did it the other day. To the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So be thinking the square root of x squared is x, the square root of 4 is 2, 1 plus, 1 minus. Now that it is completely factored, we take each of those factors individually, set them equal to 0. So 3x equals 0, x plus 2 equals 0, x minus 2 equals 0. All of these are very, very easy to solve. The first one, you divide by 3, and x equals 0. That's a solution. 0 is an option, so that's 1. Second one, subtract 2 from both sides, and x equals negative 2. Third one, add 2 to both sides. X equals positive 2. So we've got 3 solutions, 0, negative 2, and positive 2. And remember, you can plug all of these in, and they're all going to work. So you can check that out. Number 2 is the exact same. First, is there a GCF? Yes, they're divisible by 7 and x. That would leave you with x squared minus 63 divided by 7 is 9. Again, look at that binomial. It's probably either going to be the cube pattern or the difference of squares pattern. This one, they are perfect squares. So what's the square root of x squared? X. What's the square root of 9? 3. So we're going to have 1x plus 3 and 1x minus 3. Take each factor and individually set them equal to 0. And you've got, again, 3 easy equations to solve. First one, divide by 7. 0 divided by 7 is still 0. Second one, subtract 3, and x is negative 3. Third one, add 3, and x is 3. So again, 3 solutions. All right, on number 3. Now, your first thought might be, well, I should probably distribute this 5x minus 1 through. That's actually not what you want to do on problems like this. You want to leave that alone. You want to just look at this trinomial in the second parenthesis and factor it. So this one's technically already a factor, so just leave it alone. And here is their GCF. I do not see one. Nothing's in common. So that means there's a coefficient on the squared term. We've got to think about that magic number. 2 times 18 is 36. So we're looking at the factors of 36 that add to 15. So what are the factors of 36? There's 1 times 36. 2 times 18, 3 times 12, and I'm going to stop there because I noticed that 3 and 12 do add to 18. So remember, we're going to break 15x into 3x plus 12x. That's still 15x. We're going to rewrite the plus 18 and the 2x squared, and we need a plus sign. We made that 4-term polynomial on purpose for a reason, to factor it by grouping. So we look at the first 2 and the second 2. In the first 2, there's an x in common. If you were to divide by x, that leaves you with 2x plus 3. In the second group, There's a 6 that divides both of those, so I put plus 6 because it's a positive 6. If you were to divide by 6, that would be 2x plus 3, which is great because those parentheses match. So we would have the 2x plus 3 that's in common, and then the leftovers in the second parenthesis, x plus 6. Don't forget the equals 0, and also definitely don't forget that first factor that was already out front. It needs to be rewritten. So now it's completely factored. We take each factor and individually set them equal to 0. So 5x minus 1 equals 0, 2x plus 3 equals 0, and x plus 6 equals 0. Each of these take just a couple seconds to figure it out. Plus 1, so 5x equals 1. Divide by 5, and x is 1/5. Second one, subtract 3. 2x equals negative 3. Divide by 2, and x is negative 3/2. And then the last one, just subtract 6, and x is negative 6. So there you go, 3 solutions once again. All right, next one, number 4, same thing. Don't distribute. Just look at that second trinomial and make your magic number 2 times 15 of 30. So we're looking at the factors of 30 that add to 13. So you've got 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Which of these add and make 13? Of course, 3 and 10 add to 13. So we're going to break down negative 13x into a negative 3x and negative 10x. That is still the same as negative 13x. The other two terms get rewritten. And we did that to group them together. So group the first two and the second two. Again, there's an x in common there. If you were to divide by x, that leaves you with 2x minus 3. In the second group, we don't want our first term to be negative. And there's a 5 in common. Divide by negative 5, and you've got 2x minus 3, which is great because those parentheses match. So if you were to factor that 2x minus 3, you've got the leftovers of x minus 5. And then don't forget about that 3x minus 2 that's out front, all equal to 0. So now, all we have to do is take each factor and set them individually equal to 0. So that we would add 2, 3x equals 2, divide by 3, and x is 2/3. On this one, add 3, 2x equals 3, divide by 2, and x is 3/2. And on this one, just takes an addition of 5, and x equals 5. Excuse me. So there you go, 3 solutions to those. All right, and then 5 and 6 are going to, again, be pretty similar to each other. Remember, your first step is their GCF. So all of these are divisible by 2, and there's an x in common. If you were to divide by 2x, that's going to leave you with x squared minus 2x minus 15, which is nice because that is, we don't have to do the magic number. We can just go straight into the parentheses. My third sign's negative, so I'm going to have 1 plus and 1 minus. I'm looking at the factors of 15 that subtract to negative 2. That's going to be a positive 3 and a negative 5. 3 times 5 is 15. 3 minus 5 is negative 2. Take each factor, individually set them equal to 0. And x is going to equal 0, negative 3, and positive 5. 6, once again, it's already set equal to 0. Is there a GCF? Yep. 5x divides all of those. It would be x squared plus x minus 6. Again, that's nice. What are the factors of 6 that subtract to the understood positive 1? That would be a positive 3 and a negative 2. Take each factor, individually set them equal to 0. And x equals 0, negative 3, and 2. So there you go, there's that front side. Again, it's pretty much the same as yesterday, just a little bit more practice. On the back, it's finding the x-intercepts of the graph of the equation. It is the same thing. So if I talked about this yesterday, if they're asked for intercepts, it's asking the same thing. So you're just going to take the quadratic that you're given and set it equal to 0. And then just solve like we did. So no squared, no coefficient. So third sign's positive. That means we're going to adopt the sign of the second for both. What are the factors of 4 that add to 5? 1 times 4. Take each one and set them equal to 0. So x equals 1 and x equals 4. Now, here's the only difference. Since they asked them for intercepts, really your answer should be coordinates. So that's going to be 1, 0 and 4, 0 as coordinates. So it just takes the x part of the coordinate, and y is 0 because, again, we set the equation equal to 0. Number 2, same thing. Take the quadratic, set it equal to 0. Factor it. My third sign is positive, so I adopt the sign of the second for both. That means I'm going to have 2 negatives in my parentheses. The factors of 8 that add to 6 are 2 and 4. Take each factor individually, set them equal to 0. So x would equal 2 and 4. So as coordinates, that's 2, 0 and 4, 0. And so you might be wondering, where do these come from? So this is what all of these quadratics look like when you graph them. So if you have no solutions, your graph never crosses the x-axis. If your quadratic produces one solution, that means the graph crosses the x-axis at exactly one point. If you have 2 solutions, it could look like this. It crosses the x-axis at 2 spots, or this. It crosses the x-axis at 2 spots. So all of these are called parabolas. And then just however many times it crosses the x-axis are the solutions of the equations. So that's just some information to think about. So same thing as yesterday. Good luck, and it shouldn't be too difficult. So have fun.